Hi, are you a YouTube creator and want to keep an eye on your analytics data with more granularity and flexibility than the YouTube Studio app provides? Then keep watching because in this tutorial, I will walk you through the process of setting up an automated data pipeline with Python using cheap Amazon Web Services to retrieve, process, and store data from the YouTube Reporting API seamlessly into the cloud. Now, what is the YouTube Reporting API? The Reporting API is one of three available APIs that YouTube provides. With the Reporting API, you can get standardized daily reports for your own channels, which can provide you with detailed statistics by dimensions like country, subscription status, gender, or age group. However, retrieving the data requires first the creation of report jobs with the API. And afterwards, the content owner needs to actively download the data from the YouTube servers as they will not be available indefinitely. Since a manual download every day will be quite cumbersome, I have set up an automated solution to retrieve and download your data using AWS products. There are a number of requirements you need for this solution, which I will not go through in detail, but I will put links and links to other YouTube tutorials into the video description. First, you need a Google account, which as a YouTube creator, you should already have. With this account, you need to create a project in the Google Cloud Developer Console and enable the YouTube APIs, the YouTube data, YouTube analytics, YouTube reporting for this project and create OAuth credentials. Important to stress here, to avoid your credentials from being revoked or expiring after a week, you need to also publish your app. Second, you need an AWS account. And for some local steps, you should also create an IAM user account with the necessary access rights to create tables and write data to certain services. And set this up also for the AWS command line interface, the CLI. In my case, I've just created a group with the Amazon Managed Policy Administrator access attached to it and created a user in that group. But you can, of course, choose to be more restrictive. Third, you should have some basic knowledge of the Python programming language and also have a local IDE such as Microsoft Visual Studio Code installed. And fourth, you should clone or download my GitHub repo with the code and see the link in the description. So following some initial setup steps, which we need to do locally, my solution works in the following way. First, a time-based Amazon EventBridge scheduler is once a day passing a dictionary of tables and some other input arguments to an AWS Lambda function. Second, this AWS Lambda function then retrieves our Google credentials from the AWS Secrets Manager, uses them to authenticate with the YouTube Reporting API, and download the newly available reports. It then processes the data somewhat to fit into the data model of the serverless NoSQL database AWS DynamoDB and uploads them there. Third, with properly set up CloudWatch alerts, we can get an email notification via SNS if something goes wrong. For instance, sometimes there can be issues accessing the Google API. And fourth, since some of the YouTube reports might be corrected by YouTube at a later stage, we have a different Lambda function that does a monthly cleanup of the database, only retaining the record with the latest creation date for each combination of report dimensions. Now, both Lambda and DynamoDB belong to the class of serverless applications of AWS, which means you do not provision any hardware running in the background all the time. Instead, AWS will set up the infrastructure automatically when needed and bill you only for the time the applications are actually running. And this will be much cheaper for smaller applications. And both Lambda and DynamoDB are also part of the always free products within the free tier program, meaning that A certain amount of usage for these tools is free every month. I have been running this solution for about a month now, and the currently projected costs for this month stand at 2 US cents, which could even be reduced if I deleted a file from my online storage. Now, why did I choose AWS as the cloud provider for my solution and not Google Cloud Platform or Microsoft Azure or something else entirely? Well, this was simply a matter of preference. In my previous job, I had worked a bit with AWS and also got the certification as a developer associate, but I never got to work with it much hands-on. So I just wanted to refresh my memory a bit. But both Azure and GCP also have similar serverless products, and they also have free tiers. So you can surely build up similar solutions there if you want. The YouTube reporting API requires OAuth authentication, meaning you need a so-called access token or a refresh token if the access token expired. The access token and refresh tokens are only valid for a limited amount of time, and they need to be stored somewhere securely so that your code can access it. Since it is not possible to store this information permanently in the Lambda function environment, and it is also not advised to just store this in files on the Amazon online storage, we will be using the AWS native solution of the Secrets Manager. Our Lambda function will then use the Boto3 library to interact with the Secrets Manager and retrieve and store the secrets. To keep the function code flexible and avoid having to hard code the AWS region and the name of the secret code we use inside, we will also pass the region and secret name in the payload we send to our function. This way, we can also use the same functions for processing the data for different YouTube channels if we have multiple. And this will require different OAuth tokens. So now let's get to the local setup. As our storage for the YouTube data, we choose DynamoDB, a serverless NoSQL database, which has a free tier model for limited usage, and that is valid every month. We will be storing our YouTube data in tables named as just exactly as the report types in the YouTube API. The data for the tables stay mostly as they are, except for some data type adjustments and the creation of unique keys we need in DynamoDB. Besides the data tables, we will also be creating one table listing the processed report jobs. We can then check against this list when we contact the YouTube API so that we don't process a job multiple times. Now, to set up the Secrets Manager and the DynamoDB tables for the Lambda function to work, we need to first run some steps locally, as the initial retrieval of an OAuth token requires a manual verification by the user in the browser. And for this, I have set up a Jupyter notebook named setupdynamodb.ipynb in my repo. So let's just walk through. First of all, this notebook requires that you have downloaded your YouTube API OAuth secrets locally in a file called client_secrets.json. Second, you also need to have your AWS account and your command line interface set up so that the Boto3 library can interact with AWS. The first block of code will then prompt you to enter your AWS region and the name under which you want to store your OAuth tokens in AWS Secrets Manager. If a secret under that name does not yet exist in your account for that region, then Boto3 will create it. Then in the second block, we will use the locally stored client secrets to authenticate with the YouTube reporting API and retrieve the proper OAuth credentials. In this step, you will be automatically redirected to your browser to log in with your Google account, to authorize the Google Cloud app to retrieve your data via the API. And once you have done this, you will retrieve the credentials and store them locally, but also store them in the AWS Secrets Manager. And important to note here, if you have multiple YouTube channels, you will need to authenticate for each of them and also store the OAuth credentials in different secrets in the Secrets Manager. If this is the case, then you should run these first two code blocks twice, and in between also delete the local token.pickle file. In the next code blocks, we will be creating our tables in DynamoDB. Specifically, we are creating the tables for the YouTube data. One table logging the processing job IDs and a number of mapping tables for some variables that are encoded in integer variables. For example, the operating system. And afterwards, we are also filling these mapping tables with the correct values according to the YouTube Reporting API documentation. As I mentioned at the beginning, YouTube data reports will not be created by default. You need to first create a reports job once, and then the YouTube system will start to create reports going back 30 days and also creating daily reports going forward into the future. And in the notebook, create_report_jobs.ipynb, you can check which report types are available to you, which jobs have already been scheduled, and you can then also create your new jobs. Now in this section, I will be showing you the first Lambda function, which retrieves and processes the YouTube data and uploads it to our DynamoDB. The function code is available for you in my GitHub repo, but I just want to walk you through the code to show you what it's doing. So let's just jump right in. In the first part of the function, we have all our imports. We set up logging, which is also passed to the AWS CloudWatch. We create a global variable counting the number of API calls and the timestamp of the last API call. And then we define a lot of functions. The first function here is just a means of making sure we do not violate the request quota for the YouTube API, which is 60 requests per minute. And so if we reach the 60 requests per minute, then this function will make sure that the code will just wait a bit before making the next API call. The next two small functions are just to convert the downloaded reports data into formatting that DynamoDB can handle. Then we have a function that uploads a pandas data frame to a DynamoDB table. Then we have a function that retrieves the OAuth client token from the secrets manager. The next function is basically doing the authentication with the YouTube API, which I just showed you before. But now relies on the existing secrets stored in the secrets manager, from where it will retrieve them and would update them in case they needed to be refreshed. The names of AWS region and the secret that needs to be retrieved are stored within the payload that we will pass to the Lambda runtime, which I will show you later. And finally, we have the main function that puts everything together. So first we authenticate with the YouTube API to check which reports are available for download. Then we also check with our reports table in DynamoDB to see which ones of the YouTube server are new. For all new reports, we will download the CSV files from the YouTube API to a temporary local folder in the Lambda environment and check if there is any data contained besides the header line. If there is data inside, we will read in the file using pandas, add a new column for the report with the create time, convert the date columns to the ISO format that is compatible with DynamoDB, and also create a new composite key column, which together with the create time will be the unique identifier for any record within the DynamoDB table. Then we also need to convert any variables of type float because this is also not supported for DynamoDB. Now, this function works with a number of input arguments, namely the API job ID, the table name, and the variables which will be concatenated into the composite key, as well as the variables which need to be converted to decimal numbers. So for the function to work, we need to pass these arguments within a JSON payload to send to the Lambda function. More on this later. At the end, you have the general Lambda function handler, which is a requirement in any Lambda function and is passing the arguments to other functions within the script. Now, you saw that in the beginning, I had to import quite some modules, and these modules also need to be available to the Lambda runtime. So it is not enough to just create a Lambda function by copy pasting my codes into the AWS console. Instead, you should package your script along with the required dependencies in a zip file. What you need to do is install the dependencies in a specific folder, and do this also not for Windows, but for the Amazon Linux platform. Then you need to copy the Python script for the Lambda function inside this folder and then zip the whole folder. And in the case of this function, the size of the zip file will actually be larger than 50 megabytes, so that a direct upload to the AWS console will not be possible. So instead, you will need to upload the file to a bucket on the Amazon Simple Storage Solution, short S3, and then install it from there. And now let's go to the AWS console. We go and search for the Lambda service and then select to create a new function. We will choose author from scratch, define a name for our function, and then we choose Python 3.12 as the function runtime. Under the execution role, we will leave the defaults and have AWS create a new one for the function. Under the code menu, you can then upload the code from the zip file you have stored before in S3. Next, go to the configuration tab. In the general tab, click edit and raise the timeout of the function to something longer. For me, I set it at 10 minutes and that has worked out fine for now. Next, go to the IAM service and look for the newly created Lambda execution role. Under permission policies, you should now add policies that allow the function to have read and write access to DynamoDB and the secrets manager. For simplicity, I am simply using the AWS managed Amazon DynamoDB full access and secrets manager read write, but you can be more restrictive if you want. For example, if you want to restrict the access to specific resources. Under asynchronous invocations, you can see that if the Lambda function is invoked asynchronously, as it will be the case for us with the EventBridge scheduler, then Lambda will rerun the function again up to 2 times in case of errors. Now we should be ready to go and test our function. But how do we need to call it? Remember that we need to provide some input parameters to our function so that it knows which report job to check for, where to store the data, and which variables need to be transformed and concatenated to the composite key. This is solved by the payload, which we will send to the Lambda function. Every Lambda function expects a JSON dictionary as input with at least one key value pair. We are using this format to flexibly pass the arguments to our function. This way, we can have 2 functions with the same code, but using different OAuth credentials. Specifically, my dictionary contains a key jobs, and as value another dictionary, which in itself has as keys the YouTube report job IDs, and as values another dictionary with the parameters, which are the table name where the data should be stored, the column names of the decimal variables, and the column names of the variables, which should be concatenated to the composite key, both specified as Python lists in the square brackets. Besides the jobs, we also add key value pairs for the AWS region and the secret name to be retrieved. Go to the Tests tab, paste your dictionary into the event JSON field, provide an event name, and click Test. The function should now execute. So now that we have correctly set up our Lambda function, we want to set up a regular daily schedule to invoke the function. And for this, we use the service Amazon EventBridge. What we do is we first go to Amazon EventBridge, go to Schedules, and select Create Schedule. Then you enter a name and a description for your schedule. And under Schedule Pattern, select Recurring Schedule. Under Time Zone, you should select US Pacific Time, which is UTC -7, because according to the YouTube documentation, the days in the reports are defined for that time zone. For the schedule type, select cron-based schedule, and in the cron job, set up a schedule that is some time after midnight at US Pacific time. I have, for example, set up a cron job that is 0, 1, star, star, question mark, star, so that it executes every day at 1 a.m. For more information on the cron job syntax, check the link in the description. Now, under flexible window, you can either select that you don't want it, or you can define a flexible window if it is not important when exactly the Lambda function should be invoked. Then under the other options, they are basically optional, so you can click next. Under target API, now you should select invoke Lambda. And under Lambda, now select the Lambda function for processing the reports. Under payload, paste again the dictionary we used earlier for the test and click next. The other options are again optional. And then if you want to retrieve data for multiple channels, you need to create multiple schedules and repeat the process, now using a different payload. Now we should all be good, but there's always something that can go wrong. And in case something breaks, you should be able to get notified by AWS to check what went wrong. And we can use AWS CloudWatch alarms together with the simple notification service to set up email alerts. So first we would go to CloudWatch, go to alarms and all alarms. Then we select create alarm. And under metric, select Lambda and click one of the browse options like by function name. Then for our function, we select the error metric and click select metric. Then as a statistic, choose average and choose a longer time period than the usual runtime of the Lambda so that you would average multiple runs. I have set 15 minutes, for example. Now, under conditions, select static and select as condition greater or equal than 1. Under additional configuration, you can also set the data points in alarm to a stricter level, for example, 2 out of 2 data points, which in my example would mean that I only get notified if my Lambda function is consistently failing with an error rate of 100% in 2 consecutive 15-minute intervals. Click Next. Under actions, define that the conditions defined earlier refer to the alarm state. For send notification, you should now select to create a new topic, enter the email address that should receive the notification, and you can also further specify the email header and body for the notification. Click Next. Then we provide a name for the alarm, then click Next, review your setup, and click Create Alarm. Before we finish, I also want to quickly show you a second Lambda function I have built. According to the YouTube documentation, it can happen that YouTube revises some reports. And in that case, you can end up with duplicate records for a given day. To regularly clean up the database for outdated reports, I have set up another Lambda function which downloads from the database tables all records of the previous 2 months, groups the records by the composite key, orders them by the create time in descending order, and for all cases where multiple records exist for a given composite key, the code will instruct DynamoDB to delete the records with the older create time attribute. I then set up this function again with an EventBridge scheduler to run once a month, providing as a payload the list of tables to clean, and also set up CloudWatch alarms connected to an SNS topic. So that's it. Now you have a cheap automated cloud-based solution to archive your YouTube channel data in AWS for granular big data analysis. I might later enhance the solution by also implementing a backup of the DynamoDB to S3 so that I could make direct analytical SQL queries to analyze my data using AWS Athena, rather than just always downloading the whole table from DynamoDB. But for now, my channels are just not that successful yet, and my data size is still quite small, so it was not yet really worth the effort. Please check out my GitHub repo for the full code and experiment with the solution yourself. Also have a look at my analysis on channels dealing with the dragon boat sport. And if that gets you interested in the sport, also check out my other two channels for some dragon boat videos. Now it's your turn. Try out the solution with your own channels and let me know how it works. Also, let me know down in the comments if you have feedback, suggestions, or questions. This was my very first tutorial video, so any suggestions are welcome. If you found this video useful, please hit the like button and subscribe to the channel, because who knows, there might be more tutorials on data science and cloud engineering coming up in the future. Bye.